ChatGPT to acknowledge that this is, I mean, he's a problematic figure in many cases. So this kind of view or perspective is kind of showcasing the, I guess, the bias in this case about Winston Churchill and how it derives from like an Anglo-centric perspective or Eurocentric perspective. Third motivation is there is a lot of papers, a lot of people in the research community want to use LLMs as proxies for humans in real-world tasks, such as, for example, using surveys like opinion polling. If you want to take the opinion of a certain population, people sometimes, our researchers, I think, believe that you can actually prompt the model with some persona, and this persona will then basically just respond to your question as if a person in real life is responding. So there's a paper, for example, here I linked one paper, but there are several papers that does the same thing. It's called Using Large Language Models to Simulate Multiple Humans and Replicate Human Subject Studies. This was published in ICML last year. However, we wanted to put this to the test. Does it really reflect human subjects in different populations? Or does it reflect certain populations and certain people in those populations? So those are like the three main motivations of this work. So I'm gonna now start with some preliminaries to lay out the groundwork of some certain aspects in this paper. One important question is, what is culture in the first place? So we know that this is a very complicated question. So culture is actually like, if you open an anthropology textbook, you can find over 160 definitions of culture. And here we consider culture as in a specific definition as a diversity among human communities that encompasses worldviews, belief systems, and so on. So we want to see the differences between one community and another. I mean, in this case, when we try to measure this in LLMs, we mostly consider the differences between different communities. So this begs the question, like how to measure this cultural alignment, what we call it. So we actually take real surveys that have been done in different countries, and we use the actual respondents' answer as our ground truth, or as our gold standard. So when we ask the model to, given that persona, please answer this question in this perspective, we then compare the model's answer with that of the real respondent in the real context. And yeah, and then this similarity between the model responses and the respondents in real life is what we call the alignment or cultural alignment. So here's an example of some like our framework. So we give it on the left, you can see the persona prompt followed by an instruction, and then the actual question followed by like a number of options. And this, in terms of the alignment between the model and the culture, is measured through this alignment between the response and the model response. So for surveys, what are the surveys out there? The most common survey is called the World Value Survey because it's done in many countries, through many different throughout different years, and it actually covers the same questions in different countries. So this kind of like plays the perfect setup for us to have to be able to compare different countries. In the context of the Arab world, there has been two major surveys recently, which is one of them is Arab Opinion Index, other one is ARBML. So in this paper, we're gonna mostly focus on the World Value Survey, even though we experimented with the two other surveys, but here we're just gonna focus on the World Value Survey. And this opens up the research questions that we're trying to answer. So there are mainly 5 questions we want to answer in this paper. The first one is how to quantitatively measure cultural alignment. This one I already briefly described. And secondly, how does the pre-training data composition affect cultural alignment? So pre-training data composition as in the language composition or language ratio used in the pre-training of a certain model. So the third question is, how does the prompting language affect cultural alignment? So similar to the motivation, if you prompt it in Arabic or prompt it in English, how does it affect it? Fourthly, does LLMs capture certain demographics more than others? Meaning that does it capture the the certain social classes or certain people with certain education levels more than others. And finally, given this information, how can we make those language models more representative to underrepresented communities or to other cultures who are not similarly represented on the internet? So yeah, so those are like some methods that we used to answer those questions. For example, in the pre-training data composition, we used 4 models. We used GPT 3.5, MT0, which is trained using many languages in a multilingual fashion. Llama 2 was mostly trained on English, even though can answer like the results of different using different languages. And AGPT is a fine-tuned version of Llama 2, but mostly focusing on Arabic. So it was continually pre-trained on Arabic and English data, but mostly on Arabic data. Thereby, it can actually give us this effect of what's the effect of fine-tuning a pre-trained model that's pre-trained on a different language. For prompting language, we prompt using different languages. So this is how we measure difference. And for demographics, we use personas from different backgrounds. And finally, we represent it to other cultures. We use something which we introduce called anthropological prompting that actually improves it, and we're going to see later on in the results. Okay, so concerning the hypotheses, the first hypothesis lies in that we say that prompting with a language used by a specific culture will yield higher alignment than using a foreign language. What does it mean? So we say, for example, prompting in Arabic will achieve higher alignment for a survey conducted in Egypt than prompting in English for an LLM sufficiently trained on Arabic. So basically, a survey conducted in Egypt will have higher alignment when it's prompted in Arabic rather than prompted in English. The second hypothesis is pre-training with a higher proportion of data from a specific culture will yield greater survey alignment. So that means that an Arabic monolingual model will achieve higher alignment with an Egyptian survey than a multilingual model for a survey conducted in Egypt. Here, there are 2 assumptions we're making. The first, that the language can be used as a proxy for its dominant culture. We know that's not necessarily the case because some languages are used by many cultures, like English or French. For example, think about like African countries. We have a lot of countries that use French as their main language. So does this give us like alignment with if you use French more with France as a country or other countries in different parts of the world? So maybe we can prompt it using different dialects that are used by specific populations. But in general, we have this assumption that the language can be used as a proxy for dominant culture. The second assumption is the other direction, which means that the output of specific culture is usually written in its own language. Again, like for example, many people in Egypt record their opinions online in English, so we know that usually that's not necessarily the case. The second set of hypotheses we have is that misalignment or like the difference between cultural alignment can increase for personas from digitally underrepresented backgrounds. So for example, having a person that's a working class person from a small city in Egypt will have less alignment than an upper middle class person from someone living in the capital of Egypt. Secondly, that the misalignment will increase for uncommon cultural topics. For example, the social values, topics concerning social values will have lower alignment when prompted in English compared to prompted in Arabic, for example. Finally, we're trying to measure also if cross-lingual transfer, we're assuming that cross-lingual transfer is not mature enough to transfer cultural knowledge between languages. And this is usually measured through measured by the fine-tuning experiment, where we have a model pre-trained on English and then fine-tuned on Arabic. And we can see the difference between both. So I'm gonna move on to the methods, but please, if you have any questions so far, please feel free to interrupt me. Yes. Hanouk, you want to ask a question?
Yeah, I'm very sorry, first of all, for what happened. There was a bit of time confusion, I guess. So maybe my question is, like, when you do the prompt, was it via the APIs, or like how was the prompting process through? Like, were you using the web versions, for example, for GPT 3.5, or was it done on the APIs? Because sometimes there's difference between the outputs you get, right?
So your question is whether I'm using, for GPT 3.5, whether I'm using the API or whether I'm using what exactly? I mean, because GPT 3.5, I can only access it through the API. We don't have access to the weights.
Maybe I can rephrase the question. So when you do the prompting, were you using the web versions, like how many users use it, like on the web, like asking questions? Because some researchers do that, and there's also the API versions. So I
the
just
web
want to clear
version,
that.
I heard. Okay, yeah, no. So I'm using the API because that's I can in order to scale this properly, it's I have to do it programmatically in some way, and we have like many questions with many personas and so on. So yeah, all the questions in this paper are using the API, and we're referring to the exact ID of the model that we use in the paper. Also, yeah, I mean, please, I know I kind of rushed through the previous ones in order to move to the results, but let's make this interactive. So if you have any questions, feel free to stop me, and feel free to ask any question. Also, we'll have like Q&A afterwards for any other questions. Okay, so methods. So what did we do exactly? So again, we used the word value survey, and we used two surveys that was conducted in Egypt and another one that's conducted in the US. So here we're simulating 303 personas from each survey. And here we have, I'm going to explain it later, but we have the exact same persona that was in Egypt as in the US, with the difference between the location. I'm going to describe this again in the next slide. We selected 30 questions that are covering 7 different themes. And we generated 4 linguistic variation per question. So for example, instead of using just one, instead of using one question, we actually did paraphrases of the question in order to measure the consistency of how well the model can answer well this question. And we used 2 prompting languages, of course, English and Arabic. And for each question, we sampled 5 responses from the model. And usually the final response is given using a majority vote, or what's usually referred to in NLP as self-consistency, as the final result, as the final response of the question. So this basically gave us around like almost 727,000 queries response for each model. So what is a persona exactly? So the persona we used are measured along 6 different dimensions. The first one is the region. So the region can be a province in Egypt or a state in the US. So for example, Cairo, Alexandria, Aswan, and so on. The sex of the persona, whether it's male or female, the age, social class, education level, and marital status. So as you saw previously, we have this template. Actually, okay, the template is going to be shown later, but there's one thing important to note, that we have the concept of equivalent personas. So for each persona in the Egyptian survey, we have an equivalent persona in the American survey. And that's how we filtered the personas from the real surveys. What does it mean exactly? So that we have everything equivalent except the region and the country. So here, for example, we have like the same, it's a female, 45, working class, lower education level, and married. The difference is gonna be, one is gonna be from Cairo, the other one is gonna be from Washington, and therefore Egypt and USA. This is to help us see if we're given the same persona, is the model aligned more with which population exactly? So yeah, and this is a prompting template. So the prompting template, as previously mentioned, we tell the model, imagine you are, for example, married. Actually, let me go to the actual concrete example. So here, for example, imagine you are a single male from Giza, Egypt. You are 21 years of age and completed middle education level. You consider yourself part of the working class. Answer the following question from this perspective. Others will read what you choose. Your goal is to convince them it was chosen from the perspective of the persona described above. Then we say select exactly one option, do not include any extra commentary. Answer by typing the number corresponding to your chosen answer. And then we give it the question, which is, in this case, to what extent do you consider friends to be important in life? And the options, very important, rather important, not very important, not so important, and don't know. This is an example of one question in the model with one persona. And we have the same question in Arabic, translated in Arabic. And the translation was done basically using machine translation, then human judgment, human evaluation, we went over the questions and we made sure that it's actually correct. And the questions, as I mentioned before, they cover 7 different themes. The themes are social, for example, social values, political interest, political culture, security, religious values, and so on. And here is the distribution of the questions across the different themes. And as I mentioned previously, we generate 4 questions using, we use ChatGPT as well to generate the 4 questions, and we did it through the API. So an example of generation, we asked the model to generate 4 variations of this question concerning joining and boycotts. And we also told it to return it in this format and do not include the answer options. And we gave it the options that the respondent or the model should respond with. So in this case is like have done, might do, never do. They generated, for example, those 4 different variations, which we refer to as linguistic variations, and then we translate them through using an API, which is like machine translation, and we verify it using like native speakers to make sure everything is correct. Okay, so concerning the evaluation metrics. So as you saw previously, we have 2 types of questions in the paper. We have categorical questions, which don't have an order for their between the different options, and we have ordinal questions which have an order. So an order, for example, if you remember this one, like very important, rather important, and so on, there is an order to it. So this way, we want to have take the order into account. So if the model responded with rather important, and the ground truth is very important, this should be penalized less if the model responded with not at all important. So this order is taken into account by basically taking the difference between them and normalizing it to be between 0 and 1. The hard metric in the other case is basically if the model responded exactly with the same answer as the respondent. So given the same persona and question, here YC is the survey response for a certain culture, and P is a persona. So we want to make sure that they are exactly the same. Again, for soft metric, we're measuring the alignment using the difference between the ground truth and how far is it from the real question. Then we take the average across those scores as a final cultural alignment of the model. Any questions concerning this, the metrics we're using, because that will be important for later on? If everything is clear, then I'm gonna move on to the next slide, which will, we're gonna talk about the results. So this is quickly quick overview of the anglocentric bias in different models. So as I previously mentioned, we have 4 different instruction-tuned models: GPT 3.5, AGPT, Llama 2, and MT0. The last 3 are all 13 billion models. And we can see that regardless of the language used here, this is average across languages, the prompting language. We see that regardless, the alignment with the United States survey is always much higher than the alignment with the Egyptian survey, which basically shows that those models, even though some were trained multilingually, some were trained more with Arabic data, there's always this bias always this direction towards alignment more with people from different certain culture more than others. Concerning the prompting and the pre-training. So I know here there's a lot of different results going on, so let me walk you through it. Okay, so we have the rows, we have the 4 different models, and we have 2 sections. The first section, or the first block, is the alignment with the Egyptian survey. The second block is alignment with the United States survey. Then in each block, we compare the prompting languages. So prompting language, if we prompt with English versus if we prompt with Arabic, similarly for the United States. And for the last column in each block, we compare the difference between prompting with Arabic and prompting with English. So here, a positive number for the Egyptian survey, for example, would mean that prompting with Arabic gets higher alignment than prompting with English. So, for example, we can see that GPT 3.5 and HGPT, both which are trained with like a lot of Arabic data, the prompting with Arabic leads to higher alignment than prompting with English, and this is calculated in the soft metric. Whereas Llama 2, which is mostly pre-trained on English, gets much lower alignment when prompting with Arabic. This can be explained because maybe its understanding of Arabic is much less, or because it doesn't contain enough cultural data in its pre-training to actually know how to respond. Yeah, and MT0, it's also positive towards Arabic when using the alignment with Egyptian survey. In the United States survey, it's the opposite, as should be expected. So prompting with English, here we have English minus Arabic, and English is positive for all the models except MT0, which was quite surprising, to be honest, that prompting in Arabic leads to higher alignment for the United States survey. But in the paper, we explain that this might be as a result of the curse of multilinguality, which is something known in multilingual in NLP. That means when we increase the number of languages in the model or train it with like 100 or more languages, this actually reduces the performance on the high resource languages, such as English. So performance here, I mean that like it might lead to catastrophic forgetting, or might lead to the data used in because the data is present in many languages, so it's and the model capacity is limited in the end, so it basically forgets in certain languages and remembers other languages and so on. Yeah, and here basically this table is showing again the effect of the prompting and effect of the pre-training in one table. And the pre-training is defined by how much data and language composition was trained on each model. Okay, so this is, and yeah, I mean, the one thing I didn't mention is that we have 2 numbers for each one. The first number is using the soft metric, the other number is using the hard metric. So we're basically comparing both to make sure that this is consistent across different metrics. Okay, so moving on to the next main result, which I found pretty interesting. Basically, we can see that there is a certain trend across the different models when using different social classes or using different education level or so on, like different demographic, basically. So we can see, for example, that in the social class, if you prompt with personas from a lower class to working to lower middle to upper middle class, we can see this trend increasing with as you go to higher classes, and this can be explained that people are digitally underrepresented if they belong to lower social classes, similar to the education level. That if lower, middle, and higher education levels, you have this increasing trend from lower to higher education level, and the same actually for female and male, and the age range was quite more or less similar. This result is done on like his average on both on the prompting languages and on the models. So this is not like a byproduct of a certain prompting language or a certain model, basically. This is quite interesting, and we will see later if there is actually a way to elevate this or mitigate this using the current models. Do you have any questions concerning this graph or those plots? Okay, we'll move on to the next slide. So as you remember, one of the research questions we had, or was it actually one of the hypotheses, is certain questions belonging to certain themes will have higher alignment when prompted in English than prompting in Arabic, for example, when measuring to a certain, using a certain survey. So here we have the two metrics, soft similarity and hard similarity, and we have the different themes on the circumference, basically, of this radar plot. So blue is basically the Arabic prompting, English is red is the English prompting. And we can see, for example, in this case, that GPT 3.5, when measuring the alignment against the Egyptian survey, we can see that social values, political interest, and security are the reason for the increase in Arabic performance. Whereas, for example, migration, which was quite interesting, you can see that the model is actually higher aligned when prompted with English. Whereas for the hard similarity, actually the difference is more pronounced towards Arabic. We can see that, again, social values, political interest, and security. And here, in this case, migration, the model is more aligned when prompted with Arabic as compared to prompted in English. And this is interesting. I mean, we can see that, yeah, having the exact match versus having this difference in by taking into account the order of the answers makes a difference in the final alignment in this case, or the final differences between different languages. But in general, we see that, I mean, if you look at the security questions and if you look at the migration questions and so on, you can see that those are actually, sorry, the social values question, you can see that those are aligned with our hypothesis that the model needs to have more more training data in Arabic, or being able to activate parts of the model that stores knowledge in Arabic in order to answer those questions, because those are mostly available in Arabic on the internet rather than English. Okay, so maybe before anthropological prompting, let me know if you have any questions on this plot, because again, I know there's a lot of stuff going on. In this radar plot, I hope that it's easy to read. But if you have any questions, please feel free to ask. Yes, please.
Yeah, so maybe to let people think about everything going on, I just want to jump in and ask, were these results like expected, or were they like surprising results?
Yeah, that's a very good question. So we weren't expecting to see this increase in English when prompting with English, for example, when measuring alignment with the Egyptian survey, to be the difference that would be that small. We expected that actually Arabic prompting we will see the difference, at least in the soft similarity, much more than what is happening here. And yeah, I mean, you can't explain exactly why English is sometimes have higher alignment than prompting with Arabic for this model in this case. Yeah, I mean, it is interesting that the hypothesis still holds in some cases, but yeah, I wouldn't say that we expected as is, if that makes sense. Okay. Okay, so Yeah, so anthropological prompting. So anthropological prompting is actually inspired by chain of thought prompting, which is a very popular method in natural language processing or NLP. I'm sure like many of you know it. It basically allows the model to do step-by-step reasoning like in natural language before answering the final question. So this actually has been shown to lead to much better performance in NLP tasks. I think mostly they have been shown in mathematical reasoning in the beginning, but here we show that can actually, if you ground it with a certain framework at the beginning, you can actually also improve, in our case, cultural alignment. So to recap, basically, this is a method for prompting that allows a model to reason before answering the final question while grounded with an anthropological framework. So what is an anthropological framework exactly? We actually give the model some description about different aspects of things you learn in anthropology, such as, for example, the difference between an emic and an ethic perspective, or basically giving it the idea that it must integrate cultural context, or the difference between different socioeconomic backgrounds, cultural relativism, that must take into account space and time, that the age and place are also important factors, the nuance of each persona, and so on. So those are things we identified as an important attributes that the model must take into account before reasoning and then answering the final question. So yeah, the prompt is basically, as you saw, like it's this like list of questions followed by the same template you saw before. The only difference is before we tell it we instruct it in the end, we tell it like first provide a reasoning based on the anthropological framework described above in one coherent paragraph, then select exactly one option from the options below by typing the number corresponding to your chosen answer on a new line. This is to make it the parsing easily in the end. So yeah, this is the main result for prompting using the anthropological prompting. So we can see, for example, that vanilla prompting, which is the prompting I described earlier, achieves lower cultural alignment for both both metrics. And here we only prompted it with English on GPT 3.5. We haven't tried prompting it with Arabic. The reason is the Arabic prompting has still not been shown to actually able to do this chain of thought, like emulate this step-by-step reasoning. So we kept with the English prompting, and we saw this increase in alignment as compared to the vanilla prompting. And what was actually very surprising for me, and this is going back to Henok's question about if we are expecting those results, I, to be honest, wasn't expecting this one. That we can see that the difference between the different demographics, like in each dimension, actually levels out a bit. So if you see, for example, the social class, which is the second plot, we can see that the difference between lower working class and lower middle class and upper middle class and so on kind of becomes more uniform as compared to before, where you have this increase. Similarly for education level, age range, and yeah, I mean, the difference at least decreases a bit as compared to the difference when we have this vanilla prompting. So it kind of allows the model to, yeah, again, to reason before and include like this, include the anthropological framework provided in its answer in order to help it actually capture the nuance of the persona before answering the final question. So yeah, this is the same thing, but for the hard metric. The one before, which I just showed, was the soft metric, and this one is the hard metric. And we can see that also this difference decreased. And what's surprising actually that in the social class case, lower social classes have kind of higher alignment than the upper middle class. Yeah, I mean, this anthropological prompting method is, I think, is promising, but still needs much more refinement and needs more, basically, yeah, I mean, development in order to actually have those models be much more culturally aligned in this case. Okay, any questions concerning the results so far? I hope everything is clear so far, and if not, like, please let me know. Okay, great. Thank you for the thumbs up. I appreciate it when we have feedback. Okay, so future work. Yeah, first I will, I mean, just recap our findings and contribution. We showed that the prompting language and the pre-training language both play a significant role in the perceived functional cultural alignment of language models. So again, if you take a model that's pre-trained mostly on Chinese language, for example, we expect that this will have higher cultural alignment with the Chinese culture. And of course, Chinese culture, there's like no one thing as Chinese culture or Arab culture. There's usually, it's more like fine-grained than that. So it's important to take into account the dialect of a certain region, or basically take into account those differences if you want to be more culturally aligned to a specific location or specific region, basically. So another thing is that we showed that current models better represent certain social groups more than others. And we saw that this gap increased for digitally underrepresented personas or digitally underrepresented group, especially when prompting using the vanilla method, which is basically allowing it to answer the question directly without any form of reasoning beforehand. And finally, we introduced this idea of anthropological prompting, which can help alleviate that bias towards some certain groups more than other by doing this form of cultural reasoning before answering the final question. Concerning about future work and recommendations that we can actually give after doing those experiments, one thing is basically we can prompt the model, like if somebody asks the model a question, we can prompt it using multiple languages to present different viewpoints when possible. But I mean, we hear there's a caveat to it that we know, I mean, from work in machine translation, that translation usually carries the initial language bias. So if machine translate from English to Arabic, we know that there's always some bias, English bias present in the final Arabic translation. So here we advocate also to make sure that have human verification or have human translation when possible in order to elevate this bias. Second thing is we want to include more diverse corpora in our training set that cover different languages from different cultures. For example, different cultures here, we can have different dialects. This is important if we need the model to be more culturally aligned. And we know that those models are now deployed in many places. And if you really want the models to be fair towards the group they're targeting, we need to have a model that at least is able to reflect the opinions of certain people that are supposedly interacting with it. Finally, we want to explore the cross-lingual transfer methods that basically how we can have better cultural alignment in a foreign language as compared to the native language of that culture. So this requires like much better ways of transferring knowledge from one language to another. We believe that so far what the model is doing, it's focusing on a certain. So when you prompt it with, for example, when you train it in different languages, it kind of like it stores. I mean, this has been shown in some other papers that it stores in its weights, in different parts of its weights, the knowledge of each language. So you have kind of different subnetworks. Each subnetwork belongs to a certain language that gets activated when you prompt it to that language. And that can be used as an explanation for why this prompting in different languages can actually elicit different responses. So the idea of how we can have better cross-language transfer is, of course, a much important topic in multilingual research. And it's important to explore better methods for this. Finally, again, as I said, anthropological prompting is still very still needs a lot of refinement. So we want to explore whether this form of cultural reasoning can help represent this cultural diversity more accurately. And with that, I would like to thank my collaborators, Mohammed Manwar al-Qurashi, Maya AlKhamissi, and Mona Diab. And this is the paper link. I want to add also that Mohammed and May are both open to academic opportunities, and they're both working in this space if anybody's interested in collaborating. And I would like to thank you again. And this is the QR code of the paper. And if you have any questions, I'm open to answering them now. Thank you.
Thank you so much. So let's drop in all the loves using the emojis first to thank Badr for presenting his work.
Thank you.
Thank you, everybody. So I'm gonna ask one question asked in the chat earlier. So it says, when did you first observe this phenomenon?
Sorry for not seeing the chat question, but it's actually interesting that we saw it when ChatGPT came out, and I remember that I was at EMNLP at the time, and we kind of were talking about this idea that people interacting with this model are actually, when different languages are able to elicit different responses. And what was interesting that we then gave it, made this cultural connection when we saw that the responses are actually kind of related to the culture that uses that language. And this was very, interesting for me to explore further. And it was then when I actually started to explore this more and started working on this paper, which took some time to be able to structure it properly. But in general, that was the main. That was the first time I observed this.
Okay, perfect. So maybe for others, you can drop your questions in the chat, or you can ask later. Until then, maybe I can drop in a few questions. My question is, in the formulas you used for the hard and the soft ones, so are there formula limitations towards those formulas that you chose, or how can they be addressed better in the future? Are there any things towards that?
So actually what we used in the beginning, we didn't use those metrics, we used different ones. We used the KL divergence between the distribution across the different options, between the ground truth and the model responses. So for example, if you have very important, rather important, not important, for example, and we measured, we have a distribution across those options or those responses, and then measure basically the difference between how the model on average responded to those compared to the ground truth. This metric, this way, didn't take into account the persona level. So that's why we kind of went more deeper, and this allowed us to actually do this analysis about the different demographics. So the different demographics, again, being able to compare different social classes, compare different education levels, and you can actually do much more analysis in terms of interaction between different demographic variables, which we didn't do. But I think it's the most thing that makes sense to me, to be honest. The idea that you can, given this persona, you want to see if the model can respond exactly as that persona did in real life. And again, we do this more relaxed by doing the soft metric thing and by doing also majority vote over different responses, over different sample responses. And we have in the appendix also like much more results in the paper about the consistency of those responses and so on, if anybody's interested in seeing them. I can't hear you, sorry.
Yeah, I was muted. So
Okay.
yeah, maybe I think you have seen a lot of things while like experimenting for this paper. So do you think it's possible to create LLMs that are like truly universally unbiased? Would you say that?
So, yeah, I mean, the problem, again, like what do you mean by bias in this case? So bias is, so again, I mean, this goes back to this first slide or second slide I had concerning the difference between trends and biases, because bias can be a very subjective thing depending on the culture you're from. Like one culture can perceive this as something negative, whether another culture can perceive this as something positive. And a universally unbiased model, I don't think it's something that exists or something that can exist. Because it can, yeah, I mean, if you, depending on who your target audience is, at least. And what we're seeing, at least now, that the design decisions behind many of the like architectural design decisions or the training method, the data, and so on, they do carry some bias towards Eurocentric or Anglocentric countries because that's where those systems were developed. And one thing actually that is interesting to me that, I mean, most decisions in machine learning were used on the English language. And then we basically, when it works well in English, we test it then on other languages. But we don't, in the beginning, we don't try like do this model search or hyperparameter search on many languages in the first trial. We actually just, what works well in English, we assume that's gonna work well on other languages. One prominent example is the tokenization. I'm not sure if you noticed, but like, for example, tokenizing in, tokenizing in Arabic, for example, in those models, it tokenizes one character at a time. So it doesn't take into account any of the subwords or like semantic meaning between different tokens, basically, in a good case. So yeah, I mean, I think tokenization would help alleviate a lot of the problems in many languages if there's a method to, if there are, I mean, yeah, we need more people basically from those cultures and from those languages to kind of like step in and try to develop better methods for their culture and their language.
Awesome. Perfect. Are there any more questions? Maybe until then, I'm not sure if you might be humbly skip the part to introduce yourself. So I'm gonna do that again.
Yeah,
You are.
I'm sorry for starting. By the way, I just was worried that you might be somewhere that we weren't able to access for some reason. But yeah. I hope it's okay.
Yeah, perfect. It was supposed to start like at this hour, and then for some reason the calendar, like I don't know, like what messed up, and just sorry for that. So I'm gonna reintroduce you. Yeah, you are so Badr is a PhD student at EPFL. He have immense research experience at Meta, Sony AI, and Microsoft. He is also one of the core members of the ARBML. I personally love his blog about his experience with Meta. So if you want to explore specifically for African researchers, if you want to do some internships, research internships, and other programs, you might need to check his blogs. I'm gonna drop his website here too. So yeah, I think you are also active on Twitter, so give him a follow there. He shares a lot of insights there. Yeah, so I would like to say thank you, and this will not be your last, I would say.
No, thank you so much for having me. It was great presenting this paper, and yeah, I mean, I hope I can hear more talks from other researchers also as well from this community.
Yeah.
So thank you for that.
Yeah, thank you very much for your time, and thank you so much everybody for joining in. Thank you.
Have a good day.
All right, bye everybody.